I'm going to go ahead and share my screen. I'll start with
should be open there.
Yeah. So I'll start with some slides that I put together, just so you know what this is going to be about. All right. So hopefully you can all see that. Oh boy, you know, I should have worn my glasses. I knew I forgot something, and now the screen is blurry. Okay, so all right, I'm in PowerPoint. There is slideshow. All right, got it. I'm being recorded. That's cool. And play from start. All right.
There we go.
So okay, so here's what I'm going to talk about. I'm going to talk about building your own embedded Linux distro with yakdo. So yakdo is one of the two prominent build systems for embedded Linux. So if you need to make a product that's running Linux on it, you're either going to use yakdo or you're going to use buildroot. So we Travis showed the book. The book came out in May. You can buy it on Amazon. That short link you see, that Packet Live link, that will take you to the Amazon page where you can purchase it. So if you're thinking about doing that, I would write the last part of that down. There is a Git repo that accompanies the book. So it's got all the examples, configuration files for every chapter. They're all in there. So you don't need to type them out of the book. You can just grab them from there. And you know, this has been an ongoing thing for me because you know, as we all know, open source software breaks as you know, dependencies go stale and whatnot. So periodically, I'm publishing errata for things that no longer work or need workarounds, and you can find all that in the Git repo for the book. So yeah. So here's what I'm going to talk about for the rest of the presentation. I'm going to talk about runtime package management. So this is what you all do on your desktop computers. You know, if you're running a Ubuntu or another Linux distro, you know, you're regularly installing and updating software packages on your machine using apt. This is normally not done in the context of embedded Linux, but I'm going to show you how to do it. So what are the dangers of doing runtime packagement? You know, I'm also going to talk about the benefits, and I believe there are huge benefits to doing this. I'm going to show you how to add OPKG, which is a package manager. If you've ever used OpenWRT, it is the package manager for OpenWRT. I'm going to show you how to add that to your own yakdo image, custom built. Then I'm going to show you how you can serve IPK package feeds. So these are the packages that you build on your development machine when you're building your Linux distro. Serve those from, you know, your desktop or your laptop onto the embedded target. So you'll be able to download them from your dev machine as you build these things, which is, I find to be a huge time saver, and you'll see why shortly. And then I'm going to show you how to configure the client side of this on the embedded target. So, you know, normally that would be a Raspberry Pi, a BeagleBone Black, or whatever single board computer you're working with. In our case, I'm going to use keemu I'm going to use an emulator, an ARM64 emulated device to run the package client. Okay, so before I get back into the slides, I want to show you. I want to show you a console because I want to show you. Hold on. So you still see the slides right now, right? I'm going to stop sharing, and I'm going to share something else. So I'm going to share my VM. Let me see if I can find it. Okay, here we go. So this is Ubuntu 20.04 LTS running on Parallels. I already have Yakdo installed on here. Installing Yakdo is not a big deal. Let me increase. Can you all read this, or is it too small?
No, it's perfect over here, man.
Okay.
Yes.
All right. So installing Yakdo is no big deal. You just you clone the Git repo. So you can see the command right here. So and what's important here is like you want to be pinned to a specific release. There's releases like, I don't know, maybe every 6 months or more. You want to be on one of these stable releases. And the one I chose is the one that the book uses, and it's the Dunfell release, and these like other stable releases, these get long-term support. I don't know, 5 years or something. It's somewhere between. It's at least 2 years. So you're gonna get fairly long-term support for this this branch. And so I've already got it installed. It's going to put it in a directory called Pocky. And so you can see there, I have a Pocky directory. The first thing you want to do in order to fire up Bitbake, which is the task runner that Yakdo uses, is you're going to set up the environment. So there's a build environment script that you run inside the Pocky directory, and the last thing I put in there is the output directory. So these are build directories. If you're working on multiple projects, you're going to have multiple output directories. Like in my case, I have one for the Raspberry Pi, and I created another one for my emulator. So once I run that environment script, it sets all those environment variables. It puts me inside that build directory, and now I have all the Bitbake tools. They're in my path, and I can execute them. So let me show you what that looks like. So I'm going to do Bitbake. Actually, but I don't want to second guess myself. There is Bitbake layer. Okay, yeah. Oops. Sorry about that. Okay. So Bitbake layers show layers. So one thing you need to understand about Yakdo and Bitbake, and this is a big stumbling block for a lot of people, is that it's like a cake. You're baking a cake, and this cake has layers and layers of software stacked on top of each other. So here you can see some of those layers. There's you see there's the base layer meta, which is the sort of the most rudimentary open embedded scripts and recipes. There's the Pocky layer, which is the default yakdo distro. So when you build an image with yakdo, it's gonna default to this distro, Pocky. There are board support packages. Like there's a layer for the Raspberry Pi. I'm not compiling for the Raspberry Pi, so you don't see that here. But this yakdo BSP layer is a base layer for those different board support layers you can choose. And then there's the fourth layer is a layer that I created, and it is for my own custom distro that I defined, and I'm calling this distro macro. So you can see. So these layers, they're really just directories, and what I mean by that is, so if so that this meta macro layer, you can see it's above me in the directory tree. You know, this is just a directory with some files in it. There's the board support layer for the Raspberry Pi that we're not using. As you can see, that has a lot of stuff in it. And these layers are just Git repos. So you clone them, you know, above Pocky in your directory tree, and then you can add them to your build. So that what I did in order to add this meta macro layer, I did something like I did this. So I did bit bake layers, add layer, and then that it will get added to that list of layers. And you know, similarly, you can delete layers as you decide you no longer need them, or you're stripping down your Linux images because you know, you don't, let's say you don't need Bluetooth for a project. You can remove the Bluetooth layer or any like Wi-Fi layer that you have in your project. So I just wanted to show this to you all, just to give you a feel for what you're going to see later. I want to get more into the concepts. Now, in order to build an image, you just run bitbake, and it's, let's see, I think this is the name of the image we're working with. Let me just double check. I don't want to build something by mistake. Yes, it is. Okay. So I'm going to run that. And so I already built this, so it didn't actually do anything, right? It's already been built. Like normally this would have run thousands of tasks, and you know, it would have cross-compiled the world. But because I'd already run this before, it says, you know, hey, there's 1974 tasks, none of which needed to be run, and all succeeded. So it's all been cached. But you can see what was I building. So I was targeting this architecture, the keemu ARM64. So that's my ARM64 emulator that I'm targeting. So that's what it's compiling for, and it's compiling the macro distro, which is my distro that I defined. Normally, it would be compiling Pocky because that's the default distro, and you can see that this is an ARM64 based image. Now, how do you change these options? They are in a file called conf.local.conf, and this file it gets created every time you create one of these output build directories. So, and it's for you to modify at will. So if, oh, well, that looks terrible. Let me fix this. Come on. All right. All right. So if you go down, you can see machine selection. So here you can select what architecture you want to compile your distro for. You know, I wanted keemu ARM64, so I uncommented it. If I had not uncommented that, it would have defaulted to x86-64. And then similarly for distro, oh, it's case sensitive. All right, so see, the default distro is Pocky, but I overrode that by defining the distro to be macro. So this is big bait syntax, just so you know. It's very weird, and I won't go into the different forms of assignment, but just trust me when I say that this is overriding that. Okay, so let me get back to the slides. All right. So now that you've kind of seen what this is going to be, where we're headed, now I want to talk about, like, why would you even want to do this? Like you might be quite happy in your world of you know, developing with, say, Raspbian or you know, there's also a you know, BeagleBone. The BeagleBone org provides their own Debian distribution, you know, that runs on all the various Beagle boards, and you know, it works just like Debian does on the desktop. You know, why you know, why would you want to do anything else? Well,
so this is closer to the core on single board computers, which this allows us to do, right?
Yeah, well, it gives you more control. So basically you're you know, if you're using a Debian image, like, well, then, you know, the Debian maintainers are the ones packaging your software, you know, that you're using, except for the stuff that you're building yourself. In my world, like, you want to control everything. You want to control everything that goes on that micro SD card, and you want to do it all yourself, and you don't want to have anything in there that you're not going to use because you're just wasting space. This is the world of, you know, professional Linux for consumer devices. So I know that it's a stretch, because as devs, like, you don't want to think about these things. You have your app, and you just want to get your app running as quickly as possible. But when you need to productize something, well, you have to think, like, how am I going to deploy these things? Like, how am I going to update my device in the field, you know, regularly? I can't just go in and install some packages, right? You're not going to have that option. You know, you're going to be using something like Mender or Balena or some other OTA update solution to do that. So, you know, what is runtime package management? It's what we do every day, right? But you know, that's normally not something you can do with these embedded Linux build systems. Like, for instance, build root. This is what the Helium hotspot was built on. It does not allow for runtime package management. There's no option to add it, really. I think it
Can you
had
explain build root real quick? I mean, for folks who don't understand what build root is. Yeah,
absolutely. So build root means it's a tool that builds your root file system, and it builds your kernel, and it builds U-boot as well. So those are the main components of an embedded Linux image. You've got the bootloader, you've got your Linux kernel, And then you've got the root file system, which is like user space. It's all your libraries and apps and, you know, network manager, all that stuff that isn't in the kernel. That's your root file system. So what, you know, they call it build root because what are you building? Primarily you're building that root file system. You're selecting the packages that you want to go on that root file system, and only those packages, because your device has a specific application. It's not a general purpose computer. It's an embedded device. Now, in your case, you know, as devs, it is more of a general purpose computer, but that's not what you're going to ship to your customers. You're going to ship you're going to ship the image that's designed specifically for their device and nothing more. Does that explain it, Travis, or should I?
Yeah, it does, man. It does, and thank you for going into that. I appreciate it.
Yeah, and yakdo is the same thing. So yakdo does the same thing as build root. It just does it in a different way. Different ways. And so I'm going to show you the ins and outs of that. So okay, so all right. So what we're going to do is we're going to build our own distro, right? What does that mean? What is a Linux distro? Well, in the context of yakdo, it's a set of policies, and those policies are choices. So it's like your choice of init system. Like, are you going to use sysv init, or are you going to use systemd? Like that's a decision that you make when you define your distro. What standard C library are you going to use? Are you going to use glibc, or are you going to use muscle like Alpine does? You know, that again, that's a decision you make when you pick your distro. And then the decision we care about is package manager, because that's really what we want most out of our distro, is the ability to run a package manager. And before you can decide on a package manager, you have to decide on a package format. So, you know, that can be like RPM. In our case, it's going to be IPK. That's the package format we're going to use for all our libraries and software, because that's what OPKG uses. It's IPK based. And now, like, runtime package management means you have granularity. So it's not like, you know, it's not like the standard embedded OTA update where it's all or nothing. You know, it's the full image with Linux kernel, everything. It all gets blown away, and you're ping ponging between. And your phone works this way too. You know, like when you get an iOS update, you know, you're getting all of iOS, not just bits and pieces of it. And so that's how it works in embedded. But with runtime package management, you can say like, no, I don't have this. I want it now. Let's just install it. Or, oh, this is out of date. You know, there's a security fix. I want to update this package. And then, you know, you can just SSH in and update it, just like you can on your computer. Now, you'd never want to do that in production. Like you just don't. And people have. Right, like people do it, and they pay the price. You know, they pay the price for doing this in production. So, you know, as devs, I'm here to tell you it's okay to do this as a dev. You know, you're just trying to get your work done. You know, you don't want the OTA, you know, update stomping all over you. You know, you were in the middle of something, and that's the worst thing. It's like, oh, here comes the OTA update. I just lost it all. You know, you rebooted me, you know, thanks, Mr. Config Manager, you know, you know, you don't want that in development. You're just trying to get your job done. But there's good reasons you don't want to do this in production, because what happens when you install a package? You're extracting, you know, an archive over the file system. You know, you're running scripts, you know, before and after that extraction. If you pull the plug in the middle of that, like, you know, who knows what hit the disk? You know, it's like chances are you have a corrupt file system, and you know, depending on what you corrupted, your device could be in an unbootable state. You know, you bricked it, or it could be that it boots, but like, you know, you lost your Wi-Fi credentials or something. You know, in all intents and purposes, you're bricked there too. So, so you don't want to do this in production because of danger number one, breaking it. Now danger number two is like these package managers, they're not secure. So like, you know, there's a well-known OpenWRT exploit with OPKG that, you know, can just allow code execution by, you know, a hacker. You know, you could it does this by you know, circumventing the SSL authentication with the package server. So, you know, that you know, there are ways to get around that you know, standard authentication scheme that we use with websites in our browser. That you know, there OPKG is not that sophisticated. You can get around that authentication. You can spoof DNS. You can pretend you're the package server, you know, by pretending your downloads at openwrt.org. And so a lot of there's also like a sort of the final verification step, you know, once you've downloaded the package, which is like checksums. You know, you can get around that. So you know, you can install something that's not what you intended to install, because you know, originally the way hackers did this was the checksum was just based on the size of the file, so they could just pad bytes onto the download and get around the checksum that way. You know, then oh, okay, that's bad. So, you know, the OpenWRT fixed that. They're like, we're gonna have a cryptographic hash now. Hey, hackers found a way around that. So, you know, it's just, you don't want to do this in production. I strongly advise against it. But hey, it's great for development. You know, there's a package you want, or you're curious about, you want to try it out, just build it, install it. You know, you don't even have to reboot your device. You know, you don't interrupt your workflow. You can just keep going, and you can do it yourself. So I'm going to show you how you can do it yourself. You don't have to rely on a build engineer to do this. You can use your laptop or your desktop to serve these packages. And you know, similarly, if something comes, you know, something from the upstream shows up, a bug fix, a security patch, a feature that you really want, then you can update, you know, you can update that package on your build machine, and then by doing it then you can pull it down to your target device. You know, these are all wonderful things to have, and we're not used to having them in the embedded world.
Hey, Frank, real quick, man.
Yeah.
When we're talking about pulling these down to a development device, this is something that we can use. I mean, we have the development machine that we're working on, and then we have the device
Right. I'm
that
talking
we're
about like the pie. Like I'm talking about
right.
the pie or the big, like actually running OPKG install whatever it is you want on the target device. So
Right.
you could always do it on your dev machine, but now you can, with your own yakdo distro with OPKG on it, you can do it on your target device as well. And you're able to do it because the server that you're pulling packages from is not like OpenWRT server. It's the machine, it's your laptop, or it's the build machine running on your desktop. That's how you're able to do it.
So we're just pretending.
Yeah, you could say you're yeah, you could say you're pretending. I mean, ultimately there will be, well, no, because you're not really pretending, because this is a dev tool. Chances are you're not going to stand up a package server for your finished device. This is just, you're going to stand up. You might stand up a package server for your
Somewhere.
dev team. Yeah, internally, like in the office, for instance, where your software doesn't leak out to everybody. But once you ship the product, they're not going to get their updates this way.
But there's not going to be a difference there, right? I mean, what we're doing here is exactly what we would stand up, correct?
If you were to ship runtime package management with your device, but I'm advising that you don't do that.
Okay.
Because of the security implications of that. But yeah, if you were going to go down that route, yeah, it would be the same thing. You'd be swapping out the IP address of your local machine as the package server with whatever the host name is out there in the web for the real package server. Yeah.
Right. And so we're talking about what we're talking about here, or what you're demonstrating, can be done literally on your own development machine. And
yeah, and that's what I'm gonna do. So you're gonna see that.
Perfect.
Yeah.
I'll shut up.
Okay. No worries. No, these are good questions. It shows you're listening, and you know what's going on, and I'm not just I'm not just rambling. So thank you, Travis. So how does this help? How does this being able to install packages and update them at will help you? You're not waiting for the whole damn image to build. That this has always been a pain point on teams with an embedded device. Is like when it's all or nothing. A lot of times you're waiting for the complete Linux image to build. All this other software that you're not involved with. You're waiting for that to build. This could be half an hour, 2 hours. It depends. If you're building from scratch, it's even worse. I showed how you can just experiment. You heard about a library, could fix your problem. You could try it out. See how that goes. But most importantly, like, you can try it out yourself. You're not shoving it down the throat of the rest of your team. You can try it out yourself locally, because hey, you install one package, chances are that package has dependencies. It could add significant overhead to your image. There could be services that need to be started at runtime. Again, these are things you don't want to force the rest of your team to have to deal with until everybody's committed. But you can still try them out. You've got nothing to lose. when you're just installing packages on the fly. You know, you don't have to deal with the reboot problem. You know, you can continue doing your work after you just restart your app. You're not, or restart your service. You don't have to wait for the whole image to overwrite itself and reboot. And you know, when you're working in this way, you're revving packages, not images. And yeah, I think I already explained all that, so I no reason to dig any further into that. For me, the biggest pain point when I was using a system like Buildroot to do all this is, you know, I didn't want to have to reboot. You know, I was debugging things. You know, I'm trying to get my application working. A lot of times I would just be cross-compiling binaries on my dev machine and SCPing them to the target device, and you end up doing a lot of that, and you get lost. You know, you forget what version of what binary you wrote, and it's not a very controlled environment, and not a good way to work. Yeah.
Man, can you explain what cross-compiling means?
Sure. Yeah.
I appreciate it. Thanks,
no.
man.
Yeah. Okay. So like so the CPU on your computer, you know, it's generally not the CPU that your embedded device is running. You know, it's a different architecture. You know, you're probably running Intel on your desktop, you know, x86-64, and you're running some sort of ARM Cortex-A on your device, which means if you took a native binary from your desktop or your laptop and just plopped it onto the you know, your single board computer, it wouldn't run. It's you know, it's a different language, but it's just not going to work. So in order to get around this, you do what's called cross compilation. So on your x86 host, you are going to target, you know, ARM32 per se. So when you compile the program, it's going to compile it for the target architecture, not the host architecture. That's what cross compilation means, and it's why we have Linux embedded Linux build systems for the most part, because they streamline that whole cross compilation and linking process for you, because to do it manually is a pain in the neck. So you create this sort of like fake target environment on your build system, so that you can target the embedded architecture as opposed to your native desktop architecture.
Yeah, thank you, man. And it is a pain. It is a pain to maintain that tool chain and to keep it up to date, because it's something you really have to kind of watch after.
Right, and a lot of devs they choose not to do it. Right, like it's pretty easy to just SSH into Raspbian. You've got a compiler there. You know, you've got the tool chain on there, and you can just build things on the Pi itself. It's pretty powerful.
It's faster now than it used to be. And so, yeah, no, I see a lot of people doing that, but still, if you're doing iterations again and again and again, you've got to have the tool chain, I think. I mean, you really have to have this set up. So, yeah,
well, if you're doing it like in a, you know, CICD environment, you don't have a choice. Yeah. You know, you're not running Raspberry Pis in the cloud. You know, so you almost need to use one of these build systems. But
Frank, I got a question that came in. It said,
Sure.
so once you have everything running as you want, using packages installed via package manager, is there a way to snapshot or the environment so you can work on a lockdown yakdo recipe?
Ooh, man.
That came in from
Okay,
Larry
great.
Lang.
Yeah. So here's my suggestion for you, Larry. I wouldn't. So in order to have these sort of snapshots you're talking about of recipes, I wouldn't use this approach. There is a tool. There's something called DevTool in Yocto, and that lets you iterate on individual packages. You know, on the device. So it will take care of deploying and installing your latest binaries onto the device, and then you can go in and do your testing and debugging on the device using DevTool, and it will keep what you're calling a snapshot of a recipe. It will update the bitbake metadata so that it's pointing to the right Git branches and has the right there's Yocto uses checksums too, and those are pain to generate by hand. So DevTool will does all that automatically for you. So that's if you want to be in sync with recipes like Yocto package recipes, I would use that approach. I wouldn't use this approach.
Thanks.
Yeah, this approach is more, but this is more like what you're used to, working in Raspbian or Debian. So that's why I'm showing you this. DevTool, there's a learning curve. I think it's worth it, and I think for you, it's definitely worth learning because it sounds like you already know where you want to go. And I cover it in the book. So yeah. if you want to learn about that, by all means, buy the book and you'll learn about it.
Duly noted. Thanks.
Yeah. Okay. All right. So again, like, why do devs want runtime package management? That's what they've been doing all along. We have BeagleBones, we have NVIDIA Jetsons, Pi 4s. We're running Debian, Ubuntu. I mean, it's practically these are practically desktop computers. We're hooking up monitors, cameras. We're doing machine learning. We're installing packages. We're running, Docker containers. We can do it. like these little computers are powerful enough. So to try to take these things away from developers, I think, or say that like, no, you can't, we don't do things this way. I think, it's a losing battle. We have to get with the times, and especially with all the machine learning stuff, like those binaries are such a, like those GPU libraries, those are such a pain to compile. Like, you're not going to compile those yourself. You're going to install like Conda, and Conda is going to fetch those things for you, because I sure as heck am not going to cross compile them.
Well, even a lot of those can be run in the cloud, and I can be building models in the cloud and then pushing down locally.
Yeah. No, I'm just saying, like, say you have something like a Jetson that has a GPU that you want to use, like that. Those are the cases when you would want to get those native libraries. And there's Python wheels, that you can get, but somebody has to build that thing. Hopefully it's not you, because it's not easy.
I mean, if I want to run like license plate recognition, just on a stop sign, I mean, that's something I can easily do on a Pi 0 at this point. you know?
Right. If you
And
send it up to the cloud with, GStreamer or whatnot, yeah, by all means. But there's some people who like, they have a Jetson Nano, and they got this nice little GPU on there that they want to put to work. And so you can't really train the thing, but you can run the models on them.
You can send your training up to the cloud and get models come back to you. And so I can really just collect data, at a point, with a camera or whatnot, or and then shoot that up.
But see, this edge computing world that you're talking about, like, you expect packages, right? You expect there to be some Python library that you can just install and start playing with. Like, you don't.
To a degree.
Yeah.
I mean, I think the edge is not like an in node. I mean, I believe devices are in nodes. I believe that you can have an edge device that is more of a computational device that can then, from that point, be distributed to in nodes that are microcontrollers, right? I mean, so I can have ESP32s being in nodes, and then I have an edge node that is more of a full stack device, like a full stack Linux device that can actually say, okay, well, this edge node needs to have its ESP32 firmware updated, and I can do that for it,
Yeah. Wow. So, there are, like, Yakdo lets you build these sort of hybrid systems where you're not just building a Linux kernel, you're building microcontroller firmware, and sometimes these microcontrollers are on the same board as the Linux SOC. You can do that with Yakdo. It's not trivial.
I know that. And I know that you've worked, in the past with some Dockerized or containerized environments that they don't necessarily out of the box support this, but like Balena Cloud, Balena IO.
Right, there you go. So that's a good example right there, Travis. Docker, right?
Okay.
Like let's say you've got a Jupyter notebook, right? With some crazy machine learning model that you trained, and you've got all this great output and results, and you want to run this on a Jetson Nano. Like, wouldn't it be great to just like have a Docker image that like sets all that up and builds it all for you, rather than like going in and having to do it all yourself,
Let's break things. Yeah, absolutely, man.
So yeah, I mean, like, I get it, that's how you devs do things nowadays. And it's just what it's going to be. Everything's containerized now, and I've just accepted it. But a lot of people push back in this industry.
What are your thoughts? I mean, on containerization of everything?
I think, like, as far as the Linux SOCs go, you're spending a little more money, to get like something beefier, but like, having done it myself, like, it works fine on a Pi 4.
Does it matter at this point? I mean, does it matter? At this point in time,
maybe like, if, say, you're RAM constrained, right? Let's say you only have 512 megs of RAM. Okay, maybe that you might be pushing it. Maybe you don't want to be running Docker containers then, but let's say you've got 2 gigs, 4 gigs. I mean, that's practically a desktop, like, why not?
Yeah.
That's how I look at it.
But it's not necessarily like an in node. I mean, it's not a sensor device. It's more of a
It's not. It's you're aggregating, like, so you're aggregating the data from the sensors at this. I'll just call it a gateway, because it's connected to the internet, right? So I'll call it a gateway. You're aggregating the sensor data at the gateway device, and I you know, maybe doing some initial computation, cleaning up, and then pushing.
It's not
it
an
up to the cloud.
RV. It's an RV park. Is what we're talking about here. Yeah.
Yeah. That's a good analogy. How are we
just
doing on time?
Quick comment backing up.
Yeah.
For instance, running Docker on the very earliest hotspots can't work. Not enough RAM.
Yeah. That's what I never tested it, but that's what I would have expected.
Yeah. I picked up that work for you. Podman works.
Lucky you.
Yeah.
Oh, so there's something else called Podman that.
Yeah, it works exactly like Docker, but no
Okay.
daemon, no overhead really. Anyways.
Cool.
Quick
Yeah,
tidbit.
I mean, like Docker, you know, the company is struggling, you know, right now. So it's kind of like, you know, there's other alternatives, you know, moving in. Like I know the licensing changed. You know, everything used to be free, and now it's like it's only free to a certain extent.
You mentioned Alpine earlier.
Yeah.
And I don't know if everyone on this call knows what Alpine is, but it's a very very low, I guess, overhead. Right. I don't know if you want to explain this more.
Sure. So like a lot of times, like, you know, so say you have a Docker, you have an application that you want to run in a Docker container. So you create a Docker file that just, you know, that defines the contents of this container. The first thing you do in there is you have to pick a Linux distro, and a lot of times people will choose Alpine because it's one of the most lightweight Linux distros out there. You know, it's just like, I don't know, 10 megabytes or something ridiculous. So it just gives you the bare minimum, which in the case of your application, like you're only going to want to install the packages that you need for your application. So Alpine is a perfect fit for a lot of these you know, container workloads. Does that explain it, Travis?
Yeah, I think so. I think so.
Yeah, like I used Alpine. It's used by a lot of people for those reasons. You get much smaller images.
It's flexible.
Start up,
I mean,
they start up more quickly, and
you only put in what you need. I mean,
exactly.
it's basically, this is what I need for this project, and this is what I got to put into this job. And so you build from the bottom up rather than, you know, stripping things down, it seems. So
yeah, and that's one thing with Docker is Docker also has a layered approach to images. There's this concept of base images, and you know, you know, so you can sort of have like almost like a stacked hierarchy of images. It's pretty cool. Okay, so in the interest of time, I think I'm going to jump back to the live demo and show you what I promised. Okay, so I'm going to stop sharing the slides and start sharing the Ubuntu VM. Okay, can you all see that?
Yep.
Back? Okay, great. Okay, so let me exit out of here. All right. So we're back in that output build directory. I put this over here, and so we have an image already. So okay, let me show you a little bit. So I mentioned that. I mentioned the custom distro that we define, this thing. key mappings are kind of weird. Okay, so this is a conf file for that distro, and in here you can see I gave it a name. That's macro. I gave it a version, but most importantly, I defined what the package format is for this distro. It's IPK. So when I built the image, all the libraries, all the packages, everything that gets installed is in this IPK package format, you know, as opposed to RPM, etc. So that's one thing I did. Now the other thing I did, I think I may have not shown you this, is in the local.conf, which are sort of like these are the last overrides, you know, where I defined the target machine.
Which overrides global at this point, right?
Yeah. So these are like the very last things that get applied. So it's like the topmost layer in all the layers. So it would override everything, every layer that comes below it. So in here, there is a place where this is a big file. Hold on. Where is that? All right. So there is. Let me go back here. Okay, it's extra image features. Sorry. Okay, here it is. So in here, you see I added open SSH because, you know, hey, we all want to be able to SSH into our devices. So I put that on here, and I put package management. So by adding that last item in there, that is going to install the OPKG client onto our image so that we can do all this runtime package management stuff. So yeah, that's all I wanted to show you in there. So now I'm going to fire up. I'm going to fire up keemu. No, not yet. I am going to. So let's say I've already run keemu before. So what I'm going to do is I'm going to build curl, because while I was on there, I was like, hey, you know what? I didn't have curl on here. I want to try some HTTP requests. Let's install curl. So before I can install it, I need to build it. So in Bitbake, you know, you just do Bitbake and the name of the package you want to build. And so now it's going to build curl. It's building it. Shouldn't take very long.
So why are we doing this?
Because we want to install it. Like, we want to install it at runtime on our target device. So in order to install it, I have to serve it. But before I can serve it, I have to have built it. And because it was not part of my image as defined, there is no package built for this yet, which is why I'm building it right now, so that I can now serve it up and
Gotcha.
install the package. Is it almost done? Why is it taking so long? Okay, hopefully that will finish shortly. All right. Okay, while it's doing that, I'm going to fire up the emulator. Okay, that's too big.
And so when you talk about the emulator, what are we saying here? I mean,
okay.
anyone. Okay.
Yeah, so the emulator is keemu. It's a hardware emulator. You could think of it as kind of like, when you run like Parallels or VMware on your computer, you're pretending to be some hardware that you're not. In this case, keemu is going to pretend to be an ARM64 device, and so I have an image, right? I have a bootable image, but I'm not going to put that on a micro SD card. I'm just going to have keemu loaded up and execute it. And so you'll see like you'll see a command, you'll see a bunch of boot scroll back, and I'll get a command line, and I'll be in my simulated embedded device.
And anyone can download this, right? And anyone can pretend to be this device, right?
Yeah. Keemu's it's a well-known project. It's used in a lot of other things. If you install Docker Desktop, that keemu is how you're able to run ARM 64-bit images, Docker images on Docker Desktop on an x86 device. Is because it's running those Docker images under keemu.
This is how we pretend we're microcontrollers, huh?
Yeah, well, ARM Cortex A's. I mean, there's a lot of
come on,
there's MIPS PowerPC. There's a lot of different bizarre architectures that are supported. Okay, so let me go ahead and run that. Okay. Okay, so I'm going to go ahead and launch it. Here's what I forgot to do. I'm not in the environment, right? So run keemu is not in my path. So I need to be in the bitbake environment in order to run it and have all the bitbake tools in my path. So that's why I had to source the environment script again. I forgot to do that. So now it should run.
Boom!
Well, come on. Wow, maybe there is a lock on the file. All right, the demo gods are
they're out in force, man.
Yeah, the demo gods are not being kind to me right now. Let me see what maybe this build has a lock on.
Almost.
Yeah, I bet that's what it is. I'm going to kill this temporarily, especially since it seems to be stuck. All right. Okay. All right. Oh, so then, all right. So now it's starting, but why does that look so weird? All right, let me pull this. Come on. All right. So it's asking me for my system password. Okay. So see now it's booting the Linux kernel. This is the macro distro that I defined. So you can see there, right before the very last line, like there's the name, there's the version number, there's the machine architecture. There's no root password. You can just go right in. So here you go. I have a 64-bit ARM device, running an emulation. There's
on another device. Yeah.
Right. It's running on my Ubuntu VM.
Yeah.
Yeah. So I need to do this because I don't have a real device, embedded device in front of me. So I'm forced to do this.
And you may
Okay.
not want to have an embedded device in front of you. I mean, being able to cross compile or to work on an embedded device may cost more time. So
Yeah, it's I find it to be great. It's like there, yeah, like for instance, you don't have to deal with the whole like rigmarole of having to
yeah.
set up the network and connect to the network and DHCP and all that fun stuff. Like
And when you want to refresh, you refresh and you just purge it. Yeah.
Yeah. So it's cool. I like it. Let me back. All right. So that's that. Let's see if we can finish this damn build.
There we go.
Because if we can finish, okay. Well, hopefully it will finish. Okay. So in here, I can show you. Let me make this bigger. All right. So this. Oh wow, that's really big. Okay. Okay, so you can see like OPKG is installed here, right? Because that's what we told our distro to have. This is the package manager we wanted. So it is on our target device. It has a configuration file. What is it? And so this is the configuration file for it. And you can see there's not a whole lot in here that isn't commented out. There's these 3 URLs that are really just point to specific directories. And these are directories that are in my output build directory. So this is where the packages are being compiled.
And everything with the hash is commented out. Just
right.
for
right. Yeah. So only look at where it says source GZ. Those are the only lines that are valid. Those are the first lines that are valid. So source GZ all, and then so those 3 directories are on my host machine, and I'll show you where they are. And so I'm serving up the contents of those directories. That's where it's going to fetch the packages. And then the last 2 lines, that dest root and options lister, those were already in here. So I didn't have to add those. The only 3 lines I had to add in were this source GZ lines. And the IP address in there is the IP address of my host computer. So that's the IP address of the build machine, because that's the
local IP of that, right?
Right. Yeah. This is not on the internet, obviously. Well, this is the local IP, correct? And if you look at the IP of this machine, the keemu machine, you can see it's .2. So instead of 7.1, it's 7.2. Convenient, Wow. Okay, this damn thing is at 98%. All right, so let me go back to the emulator. So I showed you the conf file. I showed you the client. Okay, here's just to prove to you, curl isn't installed here, right? There's no curl on this image, but I want it. I want curl to be on this image. Okay. Okay, all right. It's closer. It's closer. So the nice thing is that this all should work as soon as it's done.
I tell my wife that a whole lot. All of this should work,
Okay, so let me show you the contents of that that build directory that I was talking about. So Oh, it's done. It's done. Okay,
Yeah.
wonderful. It's done. Let me just close this. Okay. All right. So, okay, I have this here. So instead of farting around looking for it, I'm just going to, I should have written it down. Okay, so this is right here. This is where the magic happens. So this directory, so this is in that output build directory, and you can see, like, you remember that conf file on the target. It was looking for our AArch64. It was looking for keemu ARM64. Those directories are known as the architecture and the machine directories. So those change depending on the type of image you're building. You know, if you're building for a different architecture, it won't be, you know, it might be just, you know, ARM7 or something instead of AArch64, and instead of keemu ARM64, that could be a Raspberry Pi. You know, that could be a Raspberry Pi 4. So that's going to vary depending on how you configured your image. So, but everything is here now. All the packages, all the metadata for those packages is all in this directory where I'm at. So I'm going to start the package server. Come on. Okay. All right. And, you know, just so I don't screw this up, make sure my IP address, yes, okay, it's 7.1. Just
this has to be as a super user here? Yes,
it does. It
Okay.
does have to be. I'm pretty sure. I don't think it, if it worked without it, I probably wouldn't have added it. Okay. Okay, so it's serving it up now. All right, I just started the package server on my dev machine. And so it's serving up all those IPK package feeds that are in that directory where I built everything. Okay,
on that address, yeah.
Yeah, so now I can actually run OKP. I can run the client now. So there it is. It just updated. Nice. It just, wow. You know, just like you do apt update in Ubuntu, same thing. Now,
you just pointed it somewhere else. Yeah.
Right. Now remember, there's no curl, right? No curl. I want curl. I think I better be that. Oh no, please. Wait. Oh, I forgot something very important. Very important. Okay, it's good thing you caught me. I forgot to update the package index. Need to do that. Okay, so let me go back to the server. Okay, kill the server. Oh, wait, all right. Let me go back up. Okay, I should have done this because after I built curl, I need to update the metadata in that directory. I forgot to do that. What is it? Temp. Just go through my history. Okay.
Python. Yeah. Here we go.
Okay. All right. Please. I don't want to look like a fool again. Ah, there we go. So,
now we got it. No space left on device.
Son of a. All right. Okay.
Yeah.
Okay. Well, you get the idea.
Yeah, exactly, man.
Close, but no cigar.
We have 3 knobs. We have 3 knobs here, man. Yeah. No.
Yeah.
No
So you
space left on device. That's horrible,
so,
dude.
yeah, I don't know what the hell it's using this space.
Everyone gets it. Everyone gets it, man.
Right.
Everyone knows what you're doing, man. Yeah.
Right.
Damn,
Right.
dude.
Okay. So, but you saw it. Like it found it. It was downloading it. It was installing it. But as you can see, it failed. But hey, at least you know it's real, right? Like it's a real demo.
Well, Frank, man, I got a question for you.
Okay.
So just to close things out, because I know we're running a little over time here.
Okay.
But tell me, what the hell does Linux have to do with embedded devices, man?
Well, okay.
I'm sorry, man. I got to put you on the spot here.
I'll make it very simple for you. If you want your thing to get on if you want your embedded device to get on the internet, you know, regardless of what it is, like if it's a microcontroller, you know, a basic sensor, like in order to get on the internet, you're going to need some kind of a gateway, right? You're gonna need that thing that connects to your home Wi-Fi or you know, cellular or whatever, you know, that thing that is plugged into the internet somehow. What is the best network software stack to be on the internet with? It is Linux. You know, it is the most, you know, mature, most robust network stack out there. So,
and I don't think people get it really. I mean, I think most people could look across their desk and not know it, but have 20 Linux devices on their desk, you know?
Yeah.
And they're probably the ones that are working. I think that's important to know, and a lot of people don't understand that. It's not just, hey.
Yeah, it's like your router. You know, your Wi-Fi router is probably running some kind of Linux on it. Probably.
I mean, I've got this dumb device here, like that has buttons on it for like Stream Deck. I don't know. I mean, everything that works probably runs Linux, honestly.
Before we end, two last things I wanted to show, because they're really important. So there's two commands, and I won't bother running them. But let's say you wanted to check for updates to packages that you already had installed on your device. You could do opkg list upgradable, and it would tell you which ones are out of date. Freaking awesome, right? And let's say, okay, you wanted to update all of those at once. You didn't want to update them, you know, one at a time. You just do opkg upgrades all of them. So you get like the full, it's almost like you get the full image update without having to do the image update. Like how beautiful is that?
Can I say something dumb here?
Okay.
What if I only want to update to a revision? Or to a particular version.
I think it allows that. Let me look at the opkg syntax. I think I remember.
I believe that is available as well, just in case you don't want to completely cut your toes off sometimes. We also
I think it keeps those other versions around. Yeah.
We have a book that you've written.
Right.
That we were going to give away on this call tonight. And
I completely forgot about that.
I mean, seriously, I could talk to you all night, man. And
all right,
but people are hitting me up and they're like,
I know who I want to give it to. It was whoever asked me about you know, remember when I was talking about DevTool? And they asked me about recipe snapshots.
Yeah,
somebody asked.
I can scroll back on that. Yeah.
Yeah. Somebody asked me about recipe snapshots. Whoever that is, they should get the book.
You win a book, and I tell you what, man, this book is badass. I've been reading it all weekend, and I haven't gotten so far into it, but it's been pretty damn amazing so far. So congratulations. whoever you are.
I think that was me.
Oh, there you go, man.
Congrats,
hey,
Larry.
Congrats,
Good
man.
question.